Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Today we'll be solving model question paper of term 2, 2021-22. So let's begin. The D block elements belong to option D, 3 group to 12 group. The relative ease of dehydration of alcohols follows the order primary is less reactive than secondary is less reactive than tertiary. Tertiary are most reactive. Next question. Question number 3. Which of the following is prepared by Gabriel thalamide reaction? So answer is option C, aliphatic primary amines. Which of the following is correct with respect to MnCN2 negative? My suggestion is that the number 6 is missing from this question. It should be MnCN6 2 negative, coordination number should be 6, and hybridization D2sp3. It is an inner orbital complex. Alkyl halides react with which of the following metals in dry ether to give hydrocarbons with double? So answer is sodium. It will get double number of carbon atoms as in alkyl halides. 3 important reagents are required for the conversion of propyne to acetone. Identify which of the following is not among 3. So answer is zinc dust. The other 3 are needed. The protein responsible for blood clotting is fibroin protein. Amines play important role in survival of human life. Naturally, they are found in proteins. So option B is correct answer. The next question is, the process of vulcanization of rubber takes place with sulfur. Sulfur forms cross links. When reaction is carried out between two different aldehydes or ketones in basic medium, it is called cross aldol condensation reaction. Option D. Complete the following reaction. Butene plus HBr in presence of peroxide will form butyl bromide. This is Kharash effect or peroxide effect, where the negative part of the adding molecule is added to the carbon atom which contains more number of hydrogen atoms. The oxidation number of cobalt in potassium tetracarbonyl cobalt is -1. Zymase enzyme is used for the conversion of glucose to ethyl alcohol. What is the IUPAC name of coordination compounds? So it should be oxidation state is equal to X is plus 2 into 0 plus -1 plus -1 is equal to 0. X is equal to 2. So it's diamine chlorido nitrito N platinum 2. Which reaction is used to prepare alpha halo acid? It's Helmholtz-Zielinski reaction or HVZ reaction. The source of nitrogen in Gabriel thalamide reaction of amine is thalamide. It is C6H4COCONH. How many D electrons are there in Fe2 positive? The configuration is 3d6 4s2. In di-positive ion, it will be 3d6 only, so there are 6 electrons. The scientific name of vitamin A is tocopherol. Groups like cyanides and nitrites possess 2 nucleophilic centers and are called ambident ligands. Oxidation of ketone involves carbon-carbon bond. Explain the formation of product on oxidation of 2,5-dimethyl-hexane 3-one and give its name. So this is 2,5-dimethyl-hexane 3-one. So on cleavage with a strong oxidizing agent like nitric acid, the compound will break at the point of ketone attachment. By Popov's law, the carbon double bond oxygen is attached to the smaller alkyl group. So we get an acid of this much carbon atoms. This is 2-methyl propanoic acid. Similarly, Here also on oxidation we get 2-methyl-propanoic acid. So this is the product. Its name is 2-methyl-propanoic acid. And cleavage occurs in such a way that keto group stays preferentially with the smaller alkyl group. This is Popov's law. What is meant by stability of a coordination compound in a solution? Name the factors which govern the stability of complex. So the stability of complex in solution means the degree of association between the metal ion and the ligands involved in the state of equilibrium. At equilibrium, the equilibrium constant will be concentration of products upon concentration of reactants raised to power the stoichiometric coefficient. And the factors which govern the stability of complex are two things. Number one, nature of central ion, and second is nature of ligands. So nature of central ion, smaller the size, more will be the stability. Greater the charge, more will be the stability. Electronegativity will divide the central metal ion into two categories: Class A acceptors and Class B acceptors. Class A acceptors are those which are fairly electropositive and belong to either group 1 or 2 or inner transition metals or early members of transition series 3 to 6. Whereas Class B acceptors are heavy metals, rhodium, palladium, silver, that is all those which have comparatively filled d orbitals. They will form stable complexes with ligands containing nitrogen, oxygen, fluorine, whereas Class B will form stable compounds with heavier members of nitrogen, oxygen family group members. Then central metal ion, if a chelate effect is visible, then compound will be more stable. If macrocyclic effect is there, then also the compound will be more stable. And similarly, stability also depends upon nature of ligand. A more basic ligand will have greater stability in the complex, and smaller ligand and with greater charge will also lead to greater stability. Next question, although phenoxide ion has more number of resonating structures than carboxylic acid is a stronger acid than phenol. So we can arrive at this answer by comparing the resonance structures of carboxylate ion and phenoxide ions. Carboxylic acid behaves as an acid by giving proton and forming carboxylate ion. Similarly, phenol gives proton and forms phenoxide ion. On comparing the carboxylate ion and phenoxide ion, we see that the electronic charge is more dispersed on two electronegative oxygen atoms in carboxylate ion, whereas only one electronegative oxygen atom in phenoxide ion. Also, in carboxylate ion, the negative charge resides on the more electronegative oxygen atom, whereas in phenoxide ion, the negative charge resides on the less electronegative carbon atom. So, as a result, carboxylic acids are more acidic or stronger acids than phenols. Haloalkanes undergo nucleophilic substitution reactions, whereas haloarenes undergo electrophilic substitution reactions. Explain. This is because the carbon-halogen bond in haloalkanes is polar, and this being more electronegative attracts the electrons towards itself, thereby causing a deficiency of electrons on carbon, and because this is positively charged, a nucleophile, a negatively charged nucleophile will attack here and replace halogen. So a nucleophilic substitution takes place. A stronger base will replace halogen atom. But in case of haloarenes, because of resonance, structures so arrive that negative charge resides on ortho and para and ortho positions. So because there is negative charge, a positively charged electrophile will get attracted towards the ring and get substituted. So it undergoes electrophilic substitution reaction. Next question is, define essential amino acids. Those amino acids which are needed for health and growth in human beings but are not synthesized in the human body are called essential amino acids. For example, valine, leucine, phenylalanine. These are all essential amino acids. Define enzyme. Enzymes are naturally occurring simple or conjugated proteins. acting as specific catalysts in the biochemical reactions in the living system. For example, maltase acts on maltose and hydrolyzes it. Write any two functions of carbohydrates in plants. So carbohydrates act as structural components of cells. For example, cellulose is structural component of cell wall and fibrous structure of plants. Then these carbohydrates work as body fuels and act as the main source of energy. For example, starch acts as the food reserve in plants. Differentiate between DNA and RNA on the basis of base they contain. So DNA does not contain the nitrogenous base uracil, whereas thymine base is present here. Whereas in RNA, uracil is present but thymine is not present. Arrange the following in decreasing order of acidic strength. So NO2 is an electron withdrawing group. It increases acidity as there are 3 electron withdrawing nitro groups in 2,4,6 trinitrophenol. So it will be most acidic. Lesser than that will be dinitrophenol, and then still lesser acidic strength will be of 3-nitrophenol. Explain the reaction of phenol with dilute nitric acid at 298 Kelvin. So the hydrogen at ortho or para position of phenol will get attached with the OH of nitric acid to form water. Water will be eliminated and NO2 group will be attached at nitro position at ortho and para positions. So we get 2-nitrophenol about 15% and 4-nitrophenol about 30 to 40%. What are the monomeric repeating units of nylon 6? It's caprolactam, which on heating at 533 to 543 Kelvin open up to form this unit, which polymerizes to form nylon 6. Nylon 6,6, the two monomeric units are hexamethylene diamine and adipic acid, both containing 6 carbon atoms. Write the name and structure of monomers of BuNO. So these are butyl 1,3-diene and styrene. These combine in presence of sodium to form BuNO. Draw the figure to show the splitting of the orbitals in octahedral field of ligands. So the excited 5d orbitals in octahedral field split into a set of two sets of orbitals. 3 orbitals having lower energy, which are dx, dy and dz. These are called T2T orbitals, and 2 orbitals of higher energy. These are dx square minus y square and dz square. These are called Eg orbitals. So this is the diagram. Second part, aqueous copper sulfate solution, blue in color, gives a bright green solution with aqueous potassium chloride. Explain. This is because in copper sulfate solution, the complex is tetra aqua copper 2 plus ions. So this is square planar, and water is a weak field ligand, so it causes less splitting. It is delta T. Whereas when this complex reacts with potassium chloride, it gets converted into tetrachlorido copper. This is a stronger ligand than water, so the splitting is more, so the color is bright green solution. What do you mean by denaturation of protein? A process that changes the physical and biological properties of protein without affecting the chemical properties is called denaturation of protein. Certain physical changes like change in temperature or chemical changes like change in pH, presence of salts or certain chemical reagents can cause denaturation, in which the globular protein helix gets uncoiled and forms a linear protein. This protein precipitates on when it gets denatured by denaturing agent. What are the products of hydrolysis of sucrose? So sucrose, when hydrolyzed, gets converted to glucose and fructose. What are interstitial compounds? These are those compounds which are formed when small atoms like hydrogen, carbon or nitrogen are trapped inside the crystal in the interstitial space. So they are usually non-stoichiometric. For example, titanium carbide, manganese nitride, iron hydride also. These are non-stoichiometric. What is meant by disproportionation of oxidation state? It is a process in which there is simultaneous oxidation and reduction in the same reaction of the same element. For example, this manganate dye negative ion will simultaneously undergo oxidation as well as reduction. In oxidation, it changes its oxidation state from +6 to +7. There is an increase in oxidation number, but at the same time, it undergoes decrease in oxidation from +6 to +4. This is reduction. So as it is undergoing simultaneously oxidation as well as reduction, it is called disproportionation of oxidation state. Explain why dilute sulfuric acid is added in nitration of phenol. With concentrated nitric acid in presence of sulfuric acid, phenol gives 2,4,6-trinitrophenol, that is picric acid, but yield is low because of oxidation of ring by concentrated nitric acid. So we add sulfuric acid, which will convert phenol into 2-phenol sulfonic acid and 4-phenol sulfonic acid, which when reacted with concentrated nitric acid will undergo simultaneously nitration and desulfonation to form 2,4,6-trinitrophenol or picric acid, but this time the yield will be high. So sulfuric acid is added. Alkyl halides, though polar, are immiscible with water. So in order to dissolve alkyl halides, energy is needed to overcome the polar attraction between adjacent molecules, also the strong hydrogen bonds between water molecules. But as the less energy is released when new attractions are set up between haloalkane and water molecules, which are not as strong as the original hydrogen bonds in water, hence they are immiscible with water. How will you convert chlorobenzene to biphenyls? By carrying out Fittig reaction. What we do is we heat aryl halides with sodium in the presence of dry ether to get biphenyl. Give reasons why the presence of nitro group at ortho and para position increases reactivity towards nucleophilic substitution reaction. The presence of nitro group at ortho and para position withdraws electron density from the benzene ring and therefore facilitates the attack of nucleophile in haloarenes. The carbon ion thus formed is stabilized by resonance. For example, at para position, when the nitro group is present, the attachment of OH on this carbon, which is having bond with chlorine, is a slow step. But because of resonance, the electrons of the double bond are present at ortho position as a negative charge. When in the next resonating structures, these electrons will move here and negative charge comes here. The nitro group will take up this negative charge to form a double bond here, and in the next structure the electrons migrate to this end. So as the electron density is taken from the benzene ring by the nitro group, so the nucleophilic substitution reaction is facilitated, and so the reactivity increases. Similarly, in ortho position also, the nitro group will take up the negative charge and thereby facilitate the nucleophilic addition reaction. In absence of nitro group, electrophilic substitution takes place. Grignard reagents should be prepared under anhydrous conditions because Grignard reagents are very highly reactive and they can easily react even with water and undergo decomposition to form hydrocarbons. So these are prepared under anhydrous conditions only. How will you convert aniline to bromobenzene? By diazotization, we form benzene disonium chloride. This is done by reacting with nitrous acid, which is formed in situ by reaction with NO2 and HCl at ice cold conditions. This disonium chloride When reacted with cuprous bromide in presence of HBr will form bromobenzene. This reaction is Sandmeyer reaction. Describe the following cross-aldol condensation. When two different carbonyl condense in presence of a base, reaction is called cross-aldol condensation. Acetaldehyde gets added to formaldehyde to form 3-hydroxypropanol. Decarboxylation reaction. Reactions in which the carboxylic acid lose carbon dioxide are called decarboxylation reaction. For example, salt of carboxylic acid, sodium acetate when reacted with soda lime, NaOH and CaO mixture in the ratio 3:1. Then carbon dioxide is lost as sodium carbonate and methane is formed. Similarly, electrolytic decarboxylation also involves removal of carbon dioxide. Potassium salt of acetate when electrolyzed will form ethane and carbon dioxide, QH and hydrogen. In Friedel-Crafts acylation, benzene and related products are heated with acyl halide in presence of N-hydrous aluminum chloride to form compounds where a ketonic group or an acyl group gets attached. So this reaction is called acylation reaction. The reaction can occur with acyl halide as well as with acetic anhydride. Aldol condensation reaction. Two molecules of aldehyde or ketones containing alpha hydrogen atom in the presence of dilute alkali undergo condensation to form beta hydroxyaldehydes. O gets attached to oxygen, the remaining molecule to carbon, and beta hydroxyaldehyde is formed, which when heated will eliminate water to form alpha beta unsaturated aldehyde or ketone. Illustrate the following reaction with suitable example. Hofmann bromamide reaction. Amide is reacted with bromine and KOH to undergo degradation where an amine with one carbon less is formed, methylamine, along with potassium carbonate, potassium bromide and water. Sandmeyer reaction. Disonium chloride when heated with cuprous chloride and HCl or cuprous bromide and HBr will form chlorobenzene or bromobenzene and nitrogen. This is Sandmeyer reaction. How will you carry out the following conversions? Ethanoic acid to methanamine. We first react ethanoic acid with thionyl chloride. Ethanoyl chloride is formed. In excess of ammonia, ethanamide is formed, which will undergo Hofmann bromamide reaction to form methanamine. Similarly, nitrobenzene to benzoic acid, we reduce nitrobenzene to aniline, carry out its diazotization. So we get disonium chloride, reacted with copper cyanide to get phenyl cyanide, and then we carry out acid hydrolysis to convert it into benzoic acid. So this is how we convert nitrobenzene to benzoic acid. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.